Keeper 5.4 arc length. Alright, so here's our arc length formulas if we have just a general function, like a function in terms of y or in terms of f of x. The first one is the one that we use most often, simply because usually we have a function in terms of y. But the second one we can use if our function is in terms of x. But either way, when you have a function, it's the arc length formula is the square root of 1 plus the derivative of that function squared dx. Alright, so example 1, they're giving us the function of y equals ln secant x they want us to find the arc length between 0 and pi over 4. So the first thing I'm going to do is I'm going to find my dy dx. And so remember, for the derivative of ln, you do 1 over the inside times the derivative of the inside. So you have 1 over secant times secant tan, which reduces to tan x. Alright, so now you're going to use your arc length formula to evaluate. So you're going to do the integral from your bounds of 0 to pi over 4 of the square root of 1 plus dy dx squared, which would be tan squared of x dx. To make this a little bit easier to integrate, I'm going to use the trig identity. Remember that the Pythagorean identity says that 1 plus tan squared of x is equal to secant squared. Well, the square root of secant squared is just simply secant. And the integral of secant is one that we talked about memorizing. The integral of secant is ln secant x plus tan x. And we're evaluating that from 0 to pi over 4. So when I plug in my pi over 4 and I plug in my 0, I notice that the second term is going to go away. Ln of 1 is 0. And so my final answer, I'm simply left with ln of root 2 plus 1. In example 2, we're doing the same exact thing, except for this time our function is written in terms of x. So the first thing I'm going to do is find dx dy. And when I do that, I end up with y minus 1 to the 1/2. Alright, so now I'm going to use my arc length formula to evaluate. So I'm going to do the integral from 1 to 4 of the square root of 1 plus 1 minus, or y minus 1 to the 1/2 squared, which is y minus 1. Those ones are going to cancel, so I'm left with the integral from 1 to 4 of square root of y, which is 2/3 y to 3/2 from 1 to 4. I'm going to plug in my bounds, and then I'm going to simplify that to get 14/3. Alright, so we can also find the arc length of parametric equations. So when they're written parametrically, I can find the formula, or I can find the arc length by doing the integral from alpha to beta of the square root of dx dt squared plus dy dt squared. Alright, so in this problem, we want to find the arc length, and they're giving us that x equals 3 sine t and y equals 3 cosine t. So the first thing I'm going to do is find the derivative of each x and y with respect to t. So dx dt is 3 cosine t, and dy dt is negative 3 sine t. Now I'm going to use my arc length formula. So I have the integral from 0 to 2 pi of the square root of dx dt squared, which is 9 cosine squared t, plus dy dt squared, which is 9 sine squared t. Cleaning that up, remember sine squared plus cosine squared equals 1. So if I factor out a 9, I'm actually left with 9 times 1, which is 9. The square root of 9 is 3. The integral of 3 is 3t from 0 to 2 pi. And so I'm left with a final arc length of 6 pi. Alright, so next it says use the arc length formula for the following parametric equations. Very similar, except for this time we have an argument of 3t instead of just t. So setup is the same exact way. Find your derivatives with respect to t of both functions. And so the derivative of dx dt would be 9 cosine 3t, and dy dt would be negative 9 sine 3t. Now if we use the arc length formula, we have the integral from 0 to 2 pi square root of dx dt squared, which is 81 cosine squared 3t, plus dy dt squared, which is 81 sine squared 3t. Now again, cosine squared plus sine squared equals 1, so that leaves me just the integral of root 81. The integral of root 81 is 9, root 81 is 9, and then the integral of 9 is 9t from 0 to 2 pi. And so when I plug in that 2 pi and I plug in that 0, I'm left with 18 pi. So I get an arc length of 18 pi.